Come in. Hey, I'm going into a meeting. Sorry. No problem. Can't meet now. I'll send you an email. Okay. Yeah, I would like to touch base with you this week, so that'd be great. All right, super. Okay, sorry about that. I feel fine, kind of like I'm on a KQED fund drive, and I'm watching the numbers increment. If we can get 20 people on this line, you will all get a free gift from National Public Radio. $19, we're almost over the threshold for me to start talking. Ah, there we go. We hit 20. Dun, 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 dun. Okay, so we're after 2. We've got at least 20 people on the line. So I'm going to start the meeting, and hopefully we'll continue to get some stragglers in here. So start out by wishing everyone a good afternoon and thanking you for joining the first UC AWS user group meeting of 2017. Drum roll or applause, please. So we've got a great agenda for you today. Thanks all of you for taking the time to join us. I'll start out with my usual nag about participation. 2 weeks ago, when I went out and checked the agenda document where people are signing up to share information with the group, it was blank again. So I don't think I've created the agenda document for the next 5 months, but I will be doing that this week. And again, the only way this really works in the long term and proves useful to everyone participating is if you take your turn to sign up to share with the group. And I also, on that front, want to emphasize that we're not just sharing information about our project that is in flight. There's lots of useful information and discussion that can take place on this call. So certainly if you have an AWS effort underway, we'd love to hear about it. What's going right? What's going wrong? What are your plans? Or how things are progressing. We would also like to hear if you're planning an AWS effort of any kind, what your plans are. What is the goal that you're trying to achieve? What's your architecture or design that you think is going to meet that goal? What AWS services you think you'll be using, etc. Because that is also useful information for the group at large. And you never know, you may actually be talking to someone who's done exactly that same thing or a similar thing in the past, and they can provide useful information and advice to you. So that's also another appropriate use for the call. I will even say that if you don't have an AWS project in play and you don't have an AWS project planned, but you are thinking about using AWS, or if you're having problems getting your AWS effort underway, or even starting the conversation about using AWS for a particular purpose or use case in your situation, that's also a useful discussion for us to have, because again, many people on this call have been at that particular point in time in sort of the life cycle of an effort where they're sort of working on the vision and they're wondering how sort of how do I push this forward? How do I get approval from my department, my school, my group, my campus? How do I make the case for this? How do I get funding for this, etc.? And so this is also can be used as an opportunity for you to share where you are in that process and ask questions about that. We've had things like that in the past where I think it was Carol Jordan from UCSC, is in this quandary where she has to provide the justification for a sole source contract with AWS in order to move forward with her effort because that's where the purchasing guidelines from her campus are. So she made the call out. No one else has been in that same situation. At least that admitted it on the call that I recall. But lo and behold, I was talking to someone from UCOP this morning who is also planning a large-scale AWS project, and they're in that same situation. So I'll be reaching out to them and having them, putting them in touch with Carol so that they can talk about how they're approaching this problem. And again, hopefully we can leverage the efforts that have been created elsewhere within the system and not be recreating the wheel all the time, and sort of accelerate our learning and our adoption and our progress on this front. So again, this is my plea for all of you on the phone, and also for all of you who know someone who's not on the phone who you think would have useful information to share. Please reach out to them, encourage them, bribe them, threaten and coerce them to sign up and share information with the group at large. Okay, so I think that's all the intro that I have to give now. And with that out of the way, we'll get going today with our first speaker, who is John Skelton from UC Berkeley. And he's going to share with us his experience with using intrusion detection and prevention in the AWS environment. So take it away, John. Hopefully you're on the phone and you can unmute and share your presentation, and we'll go from there.
Can you guys hear me?
I can. You're fairly faint. You could turn your volume up potentially.
Well, this is unfortunately my mic doesn't have a volume. Well, let me check here. Yeah, I'm all the way up. So unfortunately, this is what you get. I'm gonna, unless I'm too faint entirely.
No, you're certainly audible. I think you're good to go.
Okay, I'll just speak loud. So hi, my name is John Skelton. I'm with the integration team here at Berkeley. One of the services we provide the campus is apis.berkeley.edu. If folks have web programmable APIs that they want to host and don't want to deal with authentication, authorization, metering, and rate limiting, and all that good stuff, we can help them do that. One of the things that we needed to do was provide a platform for people who wanted to consume or access the web programmable APIs, that they could have a list of available APIs and make requests, and the owners of those APIs could then say yay or nay for access. So we wanted to deploy API Central to Berkeley.edu to do this. This was deployed 2 years ago I think we went production 2 years ago, and this has been running out in AWS since. The architecture for this application is fairly standard. We based it on the reference architecture for web application hosting. Hopefully lots of you have taken a look at the AWS reference architectures. If not, I respectfully suggest that it's worth your time. So if I was going to draw our individual architecture for this application, given my drawing skills, it looks more along the lines of this. So we have a front-end external ELB where we do SSL certificate termination. We have a front-end layer of Nginx proxies, and they proxy back to internal ELBs to the appropriate back-end web application servers. This is fairly fairly standard. We also have Bastion servers because old Unix habits are hard to die, hard to kill. And then we have our NAT services for egress traffic. So everything was going well and good. This was our first AWS deployment, and the security team took a look at the data that we were going to be dealing with here and the architecture, and they said this looks fine, except you need an intrusion detection. This is policy. So there wasn't a lot of information on how to do intrusion detection, prevention out in AWS that didn't cost, that wouldn't have exploded our budget. So we discussed pulling this back into on-prem, but we had already invested a great deal of work out in AWS. So, challenge accepted. What we took a look at the available options, and we selected a network intrusion detection system called Suricata. If you're familiar with Snort, Suricata directly competes in that same space. It's an open source network intrusion detection system. If you're not familiar with this type of product, it essentially takes a look at every packet, tries and attempts to match it with a database of signatures for packets that are known malicious. And then if there's a match, then there's a rule that it needs to follow. In our case, if it matches a signature, we're going to log it and drop it. So adding in Suricata into this architecture was just a matter of inserting Suricata in the data stream for all of the front end servers. That's the Bastion hosts, the NAT hosts, as well as the front end Nginx. So all traffic into and out of the VPC would have to necessarily traverse the network intrusion prevention system. And so that covers us north-south as far as traffic. There is essentially no east-west traffic. That is to say, web app A can't really talk to B, and vice versa. Due to security groups, they would have to go out to the external ELB. So all traffic into or out of the application servers really has to traverse Suricata, thus is matched against the database of known malicious packets. Any questions thus far? If not, I will continue on. Let's see. So getting started, this slide and the next slide, pretty much the summary is it's open source software. You grab it. The packages available on the AWS Linux AMI is sufficient for a configure, make, install with just a list of development packages. The only the defaults are very close to what you need as far as the configure, make, install. You do have to add NFQ. I'll be discussing NFQ in a moment. And then, of course, I had to disable the architecture optimizations in order for the AMIs to be portable across various instance types. Okay, so now we get into the nitty gritty. For folks that are not familiar with IP tables, the Linux firewall facilities, this may be a little strange. The abstract description of what's going on here is that any packet entering in the local IP tables firewall gets checked to see if it has been scanned by Suricata, and if it has not been scanned by Suricata, oops, one second. It gets jumped to a chain where Suricata will be listening. This is the boot time configuration. That is, Suricata is not yet inserted into the data stream. So essentially, at boot time, prior to Suricata launching, or after Suricata is administratively stopped, the packets are allowed to flow freely. This is the simplest, least risk way to get started. If you want to have a more stringent strategy, it's totally doable. You have to invest a bit into IP tables. So essentially, packets come in. If they are not marked, they get jumped to a chain where Suricata will be waiting for them. And if they have been marked, they are allowed to flow free. So when Suricata launches, all it has to do is insert itself. Sorry. my presentation skills are lacking clearly. So as you can see, this bolded line, this is the insertion of Suricata, the rule that jumps the packets into the NetFilter queue. So if you're not familiar with NetFilter queue, it's a way for the IP tables to send a packet to user space, where user space applications like Suricata can read that off the queue. So it's NetFilter queue. Let's see. So at this point, we need to configure Suricata to read off the NetFilter queue, which is here. So the default configuration for Suricata, the suricata.yaml, is fairly close to what you need. You just need to tell it to listen to the NetFilter queue. So we're looking for, or we're going to match the packets that come in off NetFilter, and if they're okay, we're going to mark them 1-1, which is the mark that IP tables is looking for. The last bit of plumbing we need to do is to ensure that the appropriate IP tables rule is inserted into IP tables at Suricata launch time. So here we go with the insertion here. We're simply adding the rule to the IPS chain that all packets go to the NetFilter queue. And then, of course, on shutdown, we just restart IP tables to the default. So I'm going to take a look at the before and after again real quick, make sure this is clear. So here's at boot time or post Suricata shutdown, where packets are flowing freely. And then once Suricata launches, it simply adds in the jump to the NetFilter, where Suricata will be reading in the packets. Once Suricata reads in the packets, it marks them and re-submits them to IP tables, and it starts down the IP tables chain from scratch. So if it's already been matched, then of course it does not get jumped again back into NetFilter queue. It passes freely through IP tables. We've covered this. There's a couple things. There's a couple other matters you need to deal with. One, there are two packages. They're fairly old Perl scripts that can be extremely helpful. If you deploy Suricata, the next piece is the rule set that you want to use for Suricata to match against nefarious packets. You don't want to necessarily run all the rules. In fact, in AWS, you can't run all the rules. Some of the rules won't like the way AWS does its networking, and it will confuse Suricata and generate a great deal of notifications. So you'll want to turn those off. And the way to automate enabling and disabling individual rules in the rule set is provided by Oinkmaster and Pulled Pork, which may be odd names, but this is the naming convention that spawns when the original package was named Snort. So Suricata and Snort are so similar that they can use a lot of the subsequent tools, for example, Oinkmaster and Pulled Pork. Another thing that you need to deal with is a lot of modern, like the modern TCP stacks, like in a Linux kernel, will understand that your hardware or virtual network interfaces can offer a great deal of processing power for doing the standard TCP stuff like segmentation, offload, scatter, gather, etc. And if you have these enabled, way too much of what's going on in the network stack is happening out of view of Suricata, and it confuses Suricata to no end. So you need to turn these off. It's a simple matter of adding it to the Suricata init.d script. Just turn them off and you're good to go. So once you get this plumbed in and Suricata is reading packets successfully off a NetFilter queue, and IP tables is sending all the packets to the NetFilter queue. When Suricata sees a match of a packet against something in the rule set, it's going to generate outputs. So here's an example of one. This is somebody looking for a vulnerability in PHP. So as you can see in the first output, if you're familiar with Snort, this looks very familiar. It's saying we dropped this packet because it matched this individual rule set. Here's a quick description of why, what that rule set covers, and some information on, the standard source port, IP address, destination port, and IP address. Along with that, oops, I did it again. Along with that, we get event logging. This is sort of NetFlow data. As you can see, we have event type drop, some more source IP, destination IP. This is in JSON format, which is extremely useful. We pump all of this data into our ELK stack, and we can make pretty graphs out of the rates that we are seeing nefarious packets come into our system. Okay, I did mention OinkMaster. This is a segment of the OinkMaster that shows oinkmaster.conf. So what we're going to do here is we're going to grab the latest complete rule set from our vendor. For us, it's Emerging Threats Pro rule set, and then we apply OinkMaster with our specific configuration. What we want to do is the first line here is modify all the signature IDs. Anything that says alert, we're going to switch it to drop because we're in intrusion prevention mode. We want the packet logged and dropped instead of just generating an alert. And then we have a number of signature IDs that we need to disable. As I mentioned, Suricata doesn't like how some of the networking realities of AWS, but these rules are easily disabled. Here's a segment of them. Also, as you can see, one of them says stream established, the first one, like GNU Linux yum user agent outbound likely rated packet management. If you run, yum update, there's a rule for Suricata, or a rule in the rule set to say, hey, this is going on. In this case, we don't want to disable patches, so we disable that rule. We could talk pros and cons endlessly about this approach. On the pros, it's free software. There are free signature databases, although I would encourage folks to take a look at professionally managed ones. They are substantially better than the free ones. If you're going to use free signature databases, you probably are taking on a non-trivial management consolidation of your custom-built signature databases, which that's not fun. It takes a lot of time. Highly recommend pro databases, signature databases. My end recommendation, or my end after having ran this for a couple of years now, it works very well. I would say it's important for everybody to understand that this isn't a common solution. Like folks that want to run IDS, IPS in AWS aren't looking to tools like Suricata and Snort. They're looking to cloud vendors or appliance vendors that offer AMIs, or foregoing IDS, IPS entirely and looking towards other strategies to meet security standards. So that's if anybody's considering deploying this, they may want to consider that doing Suricata or Snort is probably. You're going to be in a small group of people doing this. I've been on the Suricata discussion list now for several years, and nobody's talking about pushing this stuff out into AWS. Which, from my perspective, it's kind of unfortunate. It works very well. I've had a lot of success with it, but I will only lament so much. So that's it. If we want to open up for discussion, that'd be great. Happy to answer questions either now or later. My contact information is there if you want to have follow-on conversation.
Absolutely. Thank you very much, John. I've got a question for you, which is, you mentioned before you had to filter out some of the rules that weren't applicable to AWS. Did you define the rules you needed to filter out by trial and error, or did you go to some internet resource that had a list that says, hey, you need to disable these rules if you're working in an AWS environment?
So I have never found a the latter. So it was definitely the former. If I can jump back down to my no, Wankmaster. As you can see, this very first line, modify SID, by default, they're in alert mode, which means they're not dropped. They just generate alerts. So when you're first dealing with applying any particular rule set to your workload, you're going to want to start in alert mode and really see what's being generated and run your application through all of its various use cases uh, from really put yourself in the position of where your users will be, mobile, accessing from home, accessing from VPN, accessing from on campus, partners, etc. Really exercise the application in its in a full extent in alert mode and really understand all the alerts that you're getting. If you have not yet exposed it to the general internet or campus the alerts that you are getting are probably ones that you want to disable. So if anybody has worked with SE Linux, you often go through a similar process where you put SE Linux in um, the non-enforce mode, permissive mode, uh, run your application through its use cases, and then invest some time into allowing that that behavior. And then once you get the alerts down to only nefarious stuff, then you can put it into drop packet mode.
Okay, excellent. Thank you very much. One quick follow-on question. So, you went through a campus sort of IT security review. They said you needed IDS IPS. You went out, found this solution, designed it, implemented it, and I'm assuming shared the results or shared the implementation detail with the security group, and they accepted that as a sign-off, and you're good to go going forward.
Yeah, we've been in production for 2 years. I the security team here on campus, they're endlessly reasonable people and extremely good at what they do. I don't want to put words in their mouths. I would assume that it raised a few eyebrows that a Unix sysadmin on campus rolled their own IDS IPS system. Um, so it raised eyebrows, but ultimately we got the thumbs up. Part of
Okay.
the integration was that all the alerts that we generate gets fed directly into their existing security monitoring tools. So on campus, run a lot of Snort and other tools like that. So since the alerts, if I can, where was that alert? See that top alert is the pretty much the same format that they already ingest. So I'm just adding to their data stream. So with with the architecture as presented and full access of what we're doing to them, as well as a stream of data of our event output, as well as all the flow data that we produce, they were satisfied.
Okay, and that was actually my follow-up question, which is whether they're tapping into the solution that you've implemented in, as part of their central security, SEM solution. So it sounds like they have, and so that's all good. All right, anyone else have questions for John?
Yeah, I have a question. So John, with Suricata, how much overhead does Suricata take on the system? I mean, the CPU memory wise, is it a very small uh,
Um, so
app?
yeah, it's a great question. So the application that we have out there, API Central, doesn't generate a lot of traffic. It's important. It's a portal for administrators. Really, it doesn't drive a lot of traffic. We're running it on T2 mediums, I believe. Yes, I'm pretty sure it's T2 mediums, which is the smallest instance that it will run on. It's critical that this system has enough memory. What you do not want to see is the Linux killer take out Suricata while it's in drop mode, because packets that are not blessed by Suricata do not flow through IP tables and everything comes to a grinding halt, which isn't terrible if in our case everything's managed through auto scaling groups. So if Suricata dies, the instance is recycled and rebuilt by auto scaling groups. So it's not the end of the world, just not ideal. As far as the footprint, I was stunned at the capabilities of Suricata just on regular old raw CPU. I was using the balanced CPU and I/O instances. It's the M series, the largest M series. I generated a bunch of false traffic through it with a full set of the Suricata rules, minus the ones that don't like the AWS networking. And I was getting 80% of the I/O throughput as advertised for the instance, with 80% utilization of CPU, which was I forget what the throughput capabilities of the largest M series it was 3 years ago, but it was pretty stunning. The other thing is the latency that it introduces into the user experience is near undetectable. I was for matching every single packet going through the system to every single rule in the database, the overhead is stunningly low.
Awesome. Thanks, John.
Hey, John, a couple questions.
Yep.
Can you go up to your topology design?
Sure. This is as it says abstract. I'm leaving out some details, particularly the databases, of course, as well as auto scaling groups and databases and availability zones. But go ahead.
So the first part, the Nginx functioning as the reverse proxy. So was that because you're doing vhosting?
Yes. As you can see, we have two different applications. The idea was that with this architecture, we could just drop CloudFormation managed applications with a simple architecture of a front end internal ELB, an auto scaling group, spanning availability zones, and a database to connect into it. So a lot of the complexity in dealing with NAT and Bastion hosts and all that was taken out of the picture for deploying new applications. Does that answer your question?
Yeah. So have you looked at using an ALB instead of an ELB?
It's a great question. So this was designed 3 years ago, and we're not using a great deal of tools that I would like to be using, including the version 2 of the ELBs. We're planning API Central version 2. So all of this will give us an opportunity to really iterate over this solution. We'll take a second look at Suricata, although we will probably stick with it. Some other solutions will not be available to us. But there's the ELB version 2, as well as throwing or pushing the output of Suricata in through the AWS tools. There's CloudWatch logging, and there's a bunch of other tools, streaming data tools that may or may not be a good fit for the information that's produced. Eventually, I would like to get it staged into S3 and have the security team pull that data straight out of S3. So the answer is we will probably be using this in a year's time.
Okay. And then I guess for everyone's edification, so the Snort versus Suricata thing is like a Coke Pepsi thing. You're in one camp or you're in the other. There does seem to be anecdotal, at least in my experience, there seems to be some Snort experience out there. It's a common reference architecture, so you're definitely not alone. But not everyone talks about what they do, and especially in security.
Okay, well that's good to hear. It may be that Suricata is much smaller footprint, so less people doing it on AWS than Snort. Perhaps I should put my ear to the ground on what people are doing with Snort in AWS.
All right. Any other questions for John? Going once, going twice. Okay, thank you very much for sharing that, John. John also has a significant, as you heard, a significant amount of experience in the AWS environment with this effort and some others. And so we look forward to hearing him in the future sharing some other aspects of his AWS knowledge with us as well. Thanks for stepping up to the plate and sharing that, John. His presentation is out in the agenda, link out to his presentation, also his contact information. So if he talked about something that you'd like to follow up with him offline, please feel free to reach out to him. I'm sure he'd be glad to share. Next up on the agenda, we have Rob from actually outside the UC system, University of Washington. Are you on the line, Rob?
Here I am. Can you hear me okay?
I can hear you. Correct.
All right. Let's see. This will be real short. I know Brad from back when he was up here, and Aaron. My presentation is, so I'm new to this user group, and my presentation is basically on what we're doing at UW, how I happen to be connected, and then I'll just throw in a couple of details about one of the 40 or so AWS projects that I'm connected with. And I'm not obviously driving all of those, but I am acting in a consulting capacity to a lot of these things. Let's see. So I'm at UW, University of Washington, in research computing. I'm jointly affiliated with IT and with the eScience Institute, but primarily eScience, and I'm primarily a researcher. So I am a proxy for somebody who wants to use a cloud but doesn't know what they are doing. I also work with my colleague Amanda Tan, and at her urging, we've somebody's dying there. Should we call 911?
I think that's Carol. Carol, I hope you're okay.
My audio was off.
That's all right.
Sorry.
Oh yeah, we should probably mute everybody who's not. Let me do that real quick. And
okay, suddenly sounds good. Am I good to carry on then? Nobody can answer me because everybody's muted.
Oh, please continue. Please continue, Rob.
Okay. So as I say, I'll be really quick here. Hopefully you can see my screen. We have a website called cloudmaven.org, cloudmaven.org. And we are primarily working off a simple drop-down where we're creating content that's a translation of our internal notes. The idea is that a UW researcher can come to the site and sort of work their way through these menus and find stuff that they're interested in doing. And in my particular case, I'm going to hopefully show a page on HIPAA compliance. So currently what this means is that I have a bunch of people at UW Medicine who are interested in creating virtual machines on the cloud that have PHI, private health information. So
Rob,
I have a little...
Rob?
Yeah.
Sorry, just jumping in here. I don't actually see your screen share. Did you click the little box on the bottom that says share screen?
Oh, let me try that again. I thought I did. Share entire screen. Oh, here we go. Start sharing. Okay, so hopefully that's okay. Now it's all green and stuff.
Yeah, it's loading presentation. Says you're sharing your screen. Yep, there we go. Research computing resources.
Yep.
Okay, yes. Continue. Sorry about that.
No, it's obviously going to be much more enjoyable if you can actually see what's going on here. Okay, so I was trying to point out that my website is called cloudmaven.org, and Aaron has been interested in this, Aaron Cullich, who's on the call, in terms of contributing some of the stuff that you have going on there. So I'm delighted to have the opportunity of expanding out what we're doing and create a knowledge base for the research community. I'll probably call in on the research call, which I think is tomorrow. But just even though I'm not a strong IT person, I'm sort of trying to set up a candidate system for HIPAA compliance that would eventually be used in an operational sense. So that's more on the sense of, and more in the spirit of this meeting. So this is just a page that has a bunch of markdown that's getting converted. So this is a GitHub page, but the markdown is being converted with Jekyll, and it lists out a series of desiderata, of desirable things to have in a virtual machine. I can give you more of the backstory, but I just kind of wanted to say hi, introduce myself, and say that this is a project in flight. Actually, I started some of this stuff with Brad Dispenza, and then I've been working with the Amazon, with the AWS solutions architects to take care of some of the details. And the original source notes look something like this. So hopefully you can see what looks like a PDF of a OneNote page with pages and pages of minuscule notes and screen captures. So this is to indicate the spirit of the website that we're trying to build, where you can come to the site and sort of follow the recipe along in gory detail and arrive at a system that will be blessed and approved by CISO office, by the medical CISO. So I'll stop there, and because like I said, I'm trying to keep this very brief.
All right, thank you very much for sharing that with us, Rob. So do we have any questions for Rob? And if so, you need to unmute yourself.
That's Brad. Just for everyone's help, just because I know the pain, can you talk a little bit about some of the lessons learned from building out your portal?
If you're talking about building, you mean building the GitHub site? Where did it go?
The actual the Cloud Maven portal. So assembling all the data and getting all those elements. Are there any lessons learned there?
Yes. So I would say that for a neophyte like me, it's good to have a system that you feel is going to be stable for a while, which means I have to learn Markdown, and that's a fairly small learning curve. But this is a stronger approach right now than using something like a wiki, which gets very chaotic. And in any kind of enterprise like this, and this is about the fourth or fifth time around the block for me, the main central challenge is to work hard on the data, on organizing the content in such a way that a hypothetical person coming to the site has a better than 50-50 chance of finding what they're looking for. So I don't think that we're there yet, but keeping that in mind is a great way of helping to organize your own process of creating content. Things have logical places to fall into, and you have a structure that doesn't bombard the person with a lot of information at once, then you're well on your way to making something that's usable. And I don't claim to be there yet. But you see this across the board. You see this even with the Amazon console. They recently got rid of the landing page where you saw the 55 different technologies, and they kind of simplified it down. I thought that was a nice move, and you can still find your way into those details. But, yep, that would be my one initial thought.
I have a question, Rob. You showed the sort of the document with all the screenshots that walks people through the creation of their particular resource. Do you feel like that's going to be maintainable over time? In other words, as you mentioned, AWS is changing the UI all the time, and so you're going to have to go back in and potentially recreate all those screenshots in that documentation. Did you take that into consideration before you created or as you created this?
Yes, I did. And I'm very aware that everything that you put out here has a half-life. So 2 responses. Number one, it was better to screen cap it and have something on record that I could refer to than to not do that. And the screen capping process is fairly quick. And then number 2, really the better thing to do than creating pages and pages of documentation like this is to actually find it on the web and find a site, for example, that AWS is going to maintain where they are going to go and keep stuff up to date. So really there's some due diligence in finding the right AWS resources or YouTube links or whatever. And if you want to take that a step further, you can say your initial job is to teach the visiting researcher how to go on YouTube or how to go to AWS and find that content. That's a stronger approach because of exactly what you've pointed out.
Right. Okay, fair enough. Other questions for Rob? All right, sounds like a no. Thank you very much for sharing, Rob. And now we're going to turn the floor over to Brad Dispenza, who is actually the solutions architect from AWS for Northern California, I believe, at this point in time, even though he currently lives in Texas, of all places. And he's going to share some information with us. So go ahead and take it away, Brad.
Yeah. I'm awesomely backlit. Awesome.
Yes.
All right. So let me share out the screen, and I thought we would just kind of show some fun stuff today from the recent reInvent launch. So one of the cool services that we launched at reInvent was recognition. So what recognition is a component of our machine learning and analytic platform. And really what it's meant for is for image processing. So it's meant to be able to give context and sentiment to images. So to kind of showcase this, so what we have here, if you actually go to the console right now, you can actually see this little demo. So we've got this picture of a person on a skateboard doing an ollie. So here we've got a high confidence that this is a skateboard, some sort of sport. There are people, there's parking of some kind, so on and so forth. So let's see how it does. So I was kind enough earlier when Kurt was talking to grab a picture of him. So we are fairly confident that Kurt is a person. He is human, which is important. Beard, hair, has a head. And then from here on out, it basically kind of goes into subtle analysis, right? So the facial analysis function, again, if we upload Kurt, so here again, we can see it's a face. He does not appear to be smiling. He's wearing glasses, not wearing sunglasses. His eyes appear open. Mouth is closed. Has a beard is a lower confidence interval. Here it's 59.2, when pretty clearly he has a beard. So you can see there's a little bit of a miss there. And if we go to a comparison, we can do facial matching. So here, basically, let's say that we've got our screenshot from Kurt. And let's say that I've got a photo ID of Kurt from our badging system. So here you can see that we've got a relatively high confidence interval, that the person on the left is the same as the person on the right. What I suspect is likely throwing it off here is the boom of the microphone, but again, depending on your thresholding. So while this is kind of cute and novel, it actually does have some interesting use cases, especially for those in the research space. So if you want to do any kind of metadata extraction of large image data sets, so let's say that you've got a researcher that's doing research with the Department of Fish and Wildlife or Forestry, and you need to get it extraction of satellite images. Does this image have water in it? We're looking for maybe signs of a particular entity within the picture. The recognition program can be made to detect some of that. Out of the box, what recognition does is pattern matching based on patterns that Amazon has provided, which means that basically if I were to upload, say, PACS data, so that's data that comes from imaging equipment in a hospital, it wouldn't be able to do things like, oh, this is an aneurysm or this is a tumor. That's specialty training that would have to happen outside of the recognition program. But if you, again, were looking for, does this picture have trees in it or does it have a river flowing through it, that's something that recognition would be able to pick out. The blinking red light. Hey, Kurt, is it being recorded?
This call?
Yeah.
Yes, it is.
Okay. In a one-on-one setting, I'm happy to share an interesting anecdote about how Amazon uses this.
Okay. Fair enough.
So for folks that are interested, hit me up and I'll tell you a little bit about how we actually use this.
And I'll jump in real quick and put another plug, which is that Brad is a resource from AWS that's available to everyone who's on the call, I believe. Although people in Southern California at least used to have your own essay. He's actually visiting our site today, and we went to lunch and talked for an hour, and then we met with him for an hour talking about some of our thoughts about our next evolution within our AWS environment. So Brad and Matt are resources that are available to you, and I highly recommend that you reach out to them, schedule time with them. They're happy to come visit you at your location or talk to you remotely and share information, as Brad indicated, directly with you. He can share information under NDA that isn't available to the public, and they're always happy to help. And if for whatever reason they can't help your particular situation, they've got a wide network of contacts and can potentially point you in the right direction. They also talk to, again, many AWS customers, so they could potentially put you in touch with people who are doing similar work at a different location, either within UC or outside of the UC space. So, public service announcement over. Back to you, Brad.
Yep. So that's all I kind of quickly put together. But if anyone has any questions or anything they're curious about, happy to try and help.
Okay. Anyone out there have questions for Brad?
Yes. How do we get in touch with you?
What was the question? It was a little quiet.
How do we get in touch with you for what you said you could describe to us one-to-one how you use it?
Yeah. So if you're in Northern California, your account representative is Matt Jameson, and his email is super easy. It's mattjam@amazon.com. If you're in Southern California, so UCLA, UCSD, Irvine, your account representative is Heather Matson, and I will pull her email up in 1 second. Heather can, is it Matson H? Yeah, so Matson H. Heather can request me or another essay to come and give you guys a little chat.
Can you spell that? Matson H or Matt Jameson?
Yeah, so Matt Jameson is MATTJAM at Amazon.com. It's just Matt Jam, like gonna jam with Matt.
Yeah, I got it. Cool.
And I can plug
as Kurt mentioned.
I can put both those email addresses into the meeting agenda as well, so that you'll be able to, if you look at that an hour from now, they'll both be out there.
Thank you.
Mm-hmm.
And Kurt has an 80% chance of having a beard here, 80%.
Ah, yes. Well, I call it a beard. I'm not sure what other people call it. It's not Duck Dynasty, that's for sure. Other questions for Brad? That sounds like a no. So in that case, I will thank you all for participating today. Again, we'll urge all of you to sign up to share information with us in a future session. We'll thank again the presenters from today, as should you. And we'll remind everyone I'm still looking for the great AWS failure story. So, this is a great forum for not only sharing our successes, but also sharing our cautionary tales. So the first person who can share a really good cautionary tale where they went out and tried to do something with AWS and it failed miserably, share that story with us all, and you will get a special prize. Other than that, have a great afternoon. Thanks for joining us. As always, feel free to reach out to me directly via email, phone call, whatever. If you got feedback on how we run the meeting, ideas for how to make it better, people you think that would make great speakers, etc., I'd love to hear all of that information. I would also urge all of you to reach out to your local campus groups, because many of your campuses have cloud working groups or cloud focused groups that are carrying on these same conversations at a local level, and that's also a good way to keep track of what resources are available to you on your location, and also what activities are happening at your location. So please, don't just settle for being a part of this group, because you can sort of create a superset of resources for yourself if you're participating at the local level as well. So if there's not anything else from anyone else,
Thank you. Thank you very much.
okay, then we'll sign off for today. Thank you all very much. Thanks again to Aaron for donating the Blue Jeans platform for us to have the meeting on, and I look forward to talking to you about a month from now.
Thanks, everyone.
Thank you.
Thanks, everybody.
Bye-bye.
Bye.